Today, we're here to present moodoom, a machine learning model that predicts the risk of ER admissions. moodoom is built by a team with over 10 years of combined experience in data science as well as medical expertise. The problem we're trying to solve is to predict the probability that someone has to visit the emergency room. If we can solve this problem, that means we can improve primary patient care, improve operational efficiency, and mitigate loss. In order to understand our model, let's walk through a hypothetical patient, MCID 1044. Let's call him Ed. Ed is a male who lives in Ohio and was born in 1962. moodoom integrates all his demographic information, ICD diagnosis, pharmacy fill variants, as well as historical ER room visits to predict the risk of future ER visits.
So the first thing moodoom looks at is demographics. Basic demographic information is very important. In this case, we found a correlation between zip code and increased incidence of ER visits. Ed just happens to live in Southwest Ohio in a zip code with high incidence of ER visits. So moodoom is unique in that it looks at intervals of 9 months to make predictions for the subsequent 9 months. So at the end of the first interval, Ed has filed 30 total claims, each linked to an ICD diagnosis code. We group ICD codes broadly into their categories. Additionally, we subdivided behavioral health ICD codes, starting with the letter F, into subgroups. In that case, in the first 9 months, he filed some claims for other health conditions, but he has filed no behavioral health conditions at this time. moodoom takes all of these into consideration. So at the end of the first 9 months, moodoom predicts a 48% risk of ER visits in the next 9 months. Moving forward now, updating Ed's history for a total of 18 months. At the end of the second interval, Ed now has 2 new behavioral health ICD codes. Another thing that moodoom looks at is pharmacy fill variance, measured as the variance for time between pharmacy fills. We're using variance as a proxy for medication consistency. Evidence has shown that lack of consistency in medication increases the risk of relapse of the disease and subsequently hospitalizations. As you can see here, Ed's variance has increased over time, suggesting that he has become someone who does not fill regularly. Summary to date. So the new behavioral health claims are for nicotine dependence and anxiety disorder. Everything added together, moodoom predicts an 87% risk of ER visits in the next 9 months. And just like moodoom has predicted, at the end of the third interval, Ed has had his first and only ER visit. Based on all of 27 months of information, moodoom now predicts a 98% risk of ER visits in the next 9 months. And just like moodoom predicted, Ed has had his second, third, and fourth ER visit in the 9 months that moodoom had predicted.
And moodoom tells the story of Ed quite well, but also moodoom can tell the story for any Anthem member. moodoom is a random forest machine learning model trained on these 4 9-month intervals of time on the data that were provided. With our training time, we class balance the data from 3-to-1 negative positive ratio to ensure a highly accurate and generalizable predictor. When we assess moodoom, we assessed it by simultaneously integrating false positive rate with true positive rate. And it scores a score of 0.95, roughly 0.95 in training and test sets, where score 1 is perfect prediction, suggesting that moodoom is very, very good. When we apply moodoom to the holdout set, we scored a score of 0.89, despite missing 50% of the data in the second half of 2015, suggesting that moodoom is able to pick up subtle cues. We did exhaustive hyperparameter search when we built moodoom, and we found the best performing model at 600 trees, each with a max depth of 20 splits. moodoom tells us that location, previous ER visits, birth year, number of claims, and refill variance are the most important factors. moodoom also tells us depression and anxiety are the most important amongst all ICD-10 diagnosis codes. We further enriched moodoom with the ability to explain itself using a local interpretable model agnostic explanation, LIME. With this capability, moodoom can explain every single prediction it makes for every single member. For Ed, moodoom believes that the newly diagnosed nicotine dependence and increased refill variance are likely to be contributing to his ER risk in the following 9 months. Additionally, moodoom is scalable. We can adjust it to arbitrary intervals. We're not simply limited to 9 months. moodoom is also able to handle large volumes with fast response times because random forest models tend to be very fast by nature. And finally, we are able to add new parameters to moodoom. We're not limited to what we added here. Ultimately, moodoom improves lives. Combining high accuracy, generalizability, and explainability, moodoom can be used in primary care to proactively outreach to reduce ER risk, can be used in operational settings to improve workforce planning, and also in insurance to mitigate the lost cost of coverage. Thank you.